Alright guys, welcome back. So today, hopefully I want to show you what my project that I've worked on for a bit and the result of it. So essentially what this project will do, or this code, is it's centered around my brother's addiction to Amazon. So we always buy stuff from Amazon since it's just so much more convenient. And I made a program using OpenCV and YOLO, which is like a machine learning library. So I use that to detect if there are any boxes in the front of our door, because sometimes like I realize Amazon sends you a notification for when you get the package, but sometimes my brother's too busy or he's out, so I kind of want to know, and then I could pick it up for him. Maybe someone might steal it, so I just want to make sure. So here we're just gonna make a very simple, pretty easy, not too difficult like program that I just cooked up. Hopefully it works. I know sometimes it's kind of buggy, like it will say like, oh, there's like 3 boxes when I only hold up 1. That's again kind of still like surrounded, because my model isn't too strong. And what I mean by that is, like, I trained it maybe like 10 epochs, which is how many iterations you train it, which is not great. And I only use like 600 photos when, in reality you want to use like 6,000 or like 7,000 to train. So yeah, that's my excuse. So let's just jump right into it. Probably gonna have to screen record, so yeah. Alright guys, okay, welcome back. Now I'm going to be screen recording my whole process and what my code looks like. So let's first start in the terminal, where we want to go back to the right directory. So let's just enter that. And now we want to activate our environment. And essentially what an environment is it's kind of what the name says, right? It's an environment where you can use different versions of a library or code or language. And that's because some programs run on older languages and other ones run on like up-to-date ones. And essentially you don't want to like environments used so that like you can specify what language version you kind of want, and it just lets you specify the version you want, because sometimes you want an older version and sometimes you want a newer version, and you don't want them to clash or make a overall statement that just pretty much crashes everything, right? So that's what environments are for, and they're really useful. Alright, so on this main page we see that I have imported OS, CV2, time, and obviously our YOLO model. Alright, so obviously the code I will try to put in the description. If it's not there, sorry, just try to look up here. Anyways, these variables I set literally just give you the current time, nothing that special. And then moving on, we check to our model. So this is our actual YOLO model that I trained, and it's in this, I guess, directory. And what YOLO does is it just checks that directory, and it knows, okay, that's the trained model. Okay, now we assign it to this. All right. Now these are a couple of functions I made. They're quite straight up. I mean, take picture. What else can that do? Rectangle dimension. That's just to help me draw rectangles. Count number of boxes. I don't really use that, but it might be useful in the future. Delete directory. I'll show you why this is important later. And also delete image, which also I will show. So yeah, right now let's actually just keep these open. Why not? And you'll see here that we have a captured device. Basically this line opens our camera. This line reads that camera's every frame. And then here I just quality of life. I want to flip it so that it's the right orientation. And then furthermore, if I take an image of that current frame, see how we use our function.
our function gives us back the image path. So this is where the time variables come in handy, because look here, I'm taking my picture right now and I'm putting it at this new image file path. And what's that? It's this entire line. So up to here, I'm basically saying, okay, I want you to put this, up to here in my folders. And then here we concatenate the string or destination by adding the hour, right? So hour 12, and then minute, I don't know, 5, and then .jpeg because it's an image at the end of the day. I just did this because, again, a quality of life thing. I like to see if it's like, what time my camera took this picture, So I think that was a pretty clever design. And here, cv2.imwrite simply just writes it and saves it into a folder. And here, as you can see, it just returns that file path, this entire thing. Now, going on with the code. Let's see. Okay, so we just set that as our image file path, nothing special. But here, we like to save our results, and this is where it gets interesting. So before I knew these two lines, I was majorly confused. I had no idea how to get any variables from my model. But with this, it actually saves our predictions and the labels, which are very important, as this lets me use it for other kind of interesting things, such as drawing rectangles around my object. Now, furthermore, as you can see here, this is just an if statement to detect if it's there or not. And then this is where my predictions text file path is. So remember up here we said to save that text file? Well, this is actually the name of our text file's path. And I know that because YOLO is very smart and it saves that prediction text under the exact same name as our original image file path. See how here it's the only difference, right? It's not JPEG this time, but it will keep the same, like everything else from here to here is the exact same order, which I think is perfect because then I can just access it by just changing these. Anyways, very well done. And then what the labels thing will give you is a bunch of lines, which I'll show you later as I run it. And essentially, I just take that and it gives me the rectangle dimensions. And it gives me an X center, Y center, R width, ratio height. So I just named it ratio. R height because of ratio. Yeah, anyways, pretty self-explanatory. And then this, I just literally load up the original frame that I took a picture of. That way I can find the shape, right? The width and OpenCV is really weird. They do height and then width, but that needs a bit more explaining. I won't get that into detail today, but just know that it's actually height first and then width. Okay, moving on. What I did here is I multiplied by the X center by the image width and the Y center, image height, everything by its respective dimension. This is because the label file, which we're reading from up here, right? See how this is the file path? The text file path actually gives you, like the model returns you weird small like decimals, which you need to multiply by your actual image's dimensions in order to get like where the box is. It's just imagine it's kind of like a ratio. Anyways, let's move on. Now, from that, we know that our top left would be our X center minus R width, and also Y center minus R height. This is just our top left like corner of our box. Just imagine it like that. And if you wanted to draw a box, right, you'd have a top left and obviously a bottom right. So here we do this, but we add this time. All right, I think that's good so far, yeah. And then finally, this is the simple part. I want to take and draw a rectangle on my frame. So I input my source, which is frame, our top left coordinate, our bottom right coordinate, So that way it knows to draw like a rectangle from here to here, essentially like from the top to the bottom right. And then we give it the RGB values, but they're actually BGR, if I'm not mistaken. And finally the thickness, which is 3, which, you know, just makes it the lines thicker. And finally at this end part, all it's doing is it's just forever looping and displaying my frame that I just edited. And it's doing this over and over because I just want to see my frame. I don't really want to update that frame because I'm just taking a picture, right? It doesn't really make sense. And here it's very simple. This line just essentially means if you press the key escape, we go into this if statement. And now you're probably wondering, 27 does not look like escape. However, in CS, there's kind of just some numbers that actually represent your keyboard. So 27 just happens to represent your escape input. Anyways, if we press escape, then we call our function delete directory. What that does is exactly what it says. It deletes everything in this file path, and I'll show you that just in a quick second. And then finally we have delete image. Again, pretty self-explanatory. It will just take the image file path and delete the image there. And finally it breaks, so it escapes this while true loop. And finally we release the camera and we destroy all the windows. Now, I would like to show you the actual, I guess, actual program. Sorry, just blank. Let me actually get rid of this camera on here because it might interfere. All right, let's see if this works. Again, it's buggy because my model hasn't been trained too well. Oh yeah, like I forgot to mention that. I trained this model with only 10 epochs and around like 600 photos, which if you're new to anything CS, that machine learning, that is horrendous. Like you need at least like 6,000, I would say, at least, and do like 100 epochs, 150 even. And that's just for personal projects. The actual advanced like companies and stuff, they can go up to like millions of photos and like hundreds of thousands of epochs. So I'm not expecting too many great things. I know like from previous experience I've tested it and it's not always great, but I just came today, just wanted to show you because I was kind of excited to show this. So let's just do that. All right, so this is my Python script. Let's just call that and it should work. Alright, so right now I'm actually holding up a cardboard box and it is not working. Okay, that's not great. Let's figure out how to do this. Give me a sec. Alright guys. Sorry about that. I just figured out what was the issue and it wasn't the code at all. It was actually just because in OBS, which is what I'm using to record, it detected cameras that I was using, which I should have probably checked that out first, but it's alright. I fixed everything now, so let's try and take a photo. Let's just let this run, the script, and I'm gonna see if this actually works this time. Let's pray that it does. Perfect. So what you just see now that's appeared on the screen. Wait, let's just make sure I'm recording. Okay, thank God. Okay, there we go. See that? So what it did, right? Again, we found out that this is the X center. Hold on. Yeah, this is the X center, right? And Y center. What we did is we multiplied by the images with blah 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 and the height, and that gave us this top left corner, and we drew the rectangle all the way to this bottom right corner, and that's essentially what the code above did. Now, I know I mentioned a lot of things that I would be like, and I'll show you during the actual run. I'm gonna show you these now. Wait, what? Yeah, okay. I want to go to images, since I'm going to first show you what take image did, and it's pretty interesting. So boom, right there we go. So it took a what's it called, like an image of the current time, and it's displaying that. I don't know why I'm having 3 though. This is the one that we did. I think while I was doing my test runs, these 2 were here, so let's just delete that. And then let's go back. So that's my image, and that's what Take Picture did. Now I want to show you my actual model's prediction. So yeah, this is what the thing was just showing me. It was this exact image, and this is the accuracy. So this thinks it's 76% probably a box, which, you know, again, my model was trained in like 2 hours with 10 epoch, so it's not great. So yeah, that's what the this thing did. This is what save true and save text meant to do. And save text, actually, it doesn't save the image, right? It gives you the text. So at hour 0, minute 34, these were the coordinates. And let me explain these. This first number is our index, is our class. So in my case, my class 0 is just a box. And then these are X center, this is Y center, ratio width, and ratio height. So that's essentially what, I'm getting in my text file. Now this leads me into my next topic, which is my where is it? Rectangle dimensions function, and it's right here. So if I close up everything else because it's too distracting, you will see here, boom. What am I doing? I'm taking a predicted file path, and that's exactly going to access this. So what I'm doing right now is just some simple Python. I'm just reading the file lines with this open and then read. And then after that, I'm just doing file lines.read lines to get the first line and then splitting it. So that way I get each of these as separate things. So once it's done, it will look like this. And imagine quotation marks around each of these. All right. Oh, okay. So now, simply here, I just unpack it, right? See how I just put it as a float? I want to keep that float value as we just saw. See how it's like these are floats because they have like hella decimals? I want to keep that because that's something, that's accurate, right? I don't want to lose accuracy. So I just index and I unpack it. So X center, Y at Y center, blah, blah, blah. And I get these. And finally, I just return all 4. And that's why when down here, I unpack it, it makes sense, right? Look at that. Perfect. I get 4 returned and I unpack it with 4. There we go. I already explained everything here. This just helps me draw the rectangle that's upcoming. Finally, our delete directory and delete image. I'm not sure if these still work. They should. So what should happen is if I press escape, let's actually go back to the other page. Yeah, so let's go here again. Oh, that looks so bad. Shoot. There. If I press escape right now, it should end the program. Boom. Okay, so it has ended. And okay, this is very interesting. Now let's go back to the main one. Boom. And you'll see, seems like we have an error, but this is good because this just shows that we actually removed the file that we were trying to look at, which is good, right? Because we gave it a directory to delete, and boom, it deleted it. And it's the same thing with image. Well, maybe not. We'll see. Let's check. Images, main image. Boom, right? Remember there was a photo here? It's gone now. It removes all the photos and all the directories from before so that each time it can come up with a new one, and I just like that more. I think it looks cleaner. I don't want to come back in, manually delete all of these to save storage. It's not my thing. So I'm pretty happy about that. Alright guys, so I actually forgot to show you guys some examples where my program actually fails. So like I said before, these are due to just my model being really weak, with around 10 epochs and only like a few hundred pictures. So yeah, here, let's click on my failed examples. So these are all predictions that just flopped on me. So let's just look at this one, for example. In this case, let me get the picture for you. It literally didn't detect the box, even though right here I'm clearly highlighting, sorry, not highlighting, but I clearly have a Kleenex box in my hand, right? So that's, again, just, it has to be more precise, and to do that, I just have to train it more. And this is another scenario where it just failed because here it, for some reason, detects 2 boxes, and it thinks there's only a 54% chance that this is a box. So it might be because of my hand, I don't know, who knows. But yeah, that's just another example. Furthermore, there's probably, yeah, like the last example. In this one, it thought partially I was a box with 27% accuracy. And this was actually 90% accuracy, which is pretty good. But obviously, I'm not a box, so that's where this prediction failed. Yeah, those were just a couple of examples. I want to show you my labels. And here we see that, just like in the image, we see that there are 2 labels, because in my case, let's go back, I had 2 boxes, right? So if I had 2 boxes, it makes sense that I have 2 labels designating where those labels are. And that's pretty much all of those failed examples that I just wanted to show, and kind of just tell you, like, don't expect this to always work. Keep in mind, I'm also in a very simple environment, or background, sorry, like there's only maybe one light, a curtain here, me. But in a more complex example or background, it might mistake a lot more boxes as, maybe not being boxes, or, randomly choosing an object. So just keep that in mind. I will do an update video on this, because I am planning to hook this onto my Raspberry Pi, and that way I can use a camera, actually, some hardware outside, and use this in a real life situation. I'm also gonna, see if it's possible to make an app to get like the notifications. So yeah.
Alright guys, I just thought, kind of right to end on an outro. Thank you so much for watching. I know I will give it update later when my Raspberry Pi comes in. Can't wait for that. And then after that, I have some League of Legends stuff coming in, so be ready. I'm gonna do some pretty interesting project with that. I can't wait. I'm gonna go to sleep now because it's kind of late. But yeah, anyways, good day in coding. That's the setup right there. Pretty nice. Good night, guys.